Hi there, welcome to the video. Today, my teammates and I, which are Pablo and Sebas, are going to show you the explanation of limits approaching infinite and the differentiation rule. So, let's hit it. First, with limits approaching infinite.
The first step is to write always the limit for each step as x approaches infinite. Then, for this type of problem, we usually divide everything by the highest exponent, so in this case it's x to the cube. So we're going to proceed with that, which is 3 over x3 plus x over x to the third power minus 2x to the third power over x to the third power, and all of this divided by x2 over x to the third power minus 5x to x to the third power, and the same with the last one, x to the third power over x to the third power. So basically we divided everything by the highest exponent, and then we need to cancel out all the x's. So in this case, as x approaches infinite, never forget that. In this case we end up with 3 over x3 plus 1 over x2 minus 2, because in this case all the x's cancel out and we end up with minus 2. All of this divided by 1 over x2, we cancel out the x's, the same as on the top, 5 over x2, and we add a 1 because we cancel out all the x's and we assume there's a 1 besides the x. So the next step is we need to add an infinite value, because here we are shown that x approaches infinite. So we need to add the infinite value to each of the x's we have remaining. So in this case we have 3 over infinite to the cube plus 1 over infinite to the second power minus 2. We do the same thing for the bottom, which is 1 over infinite to the second power minus 5 over infinite to the second power plus 1. In these cases we can assume that an infinite on the lower part is automatically a 0. So we assume that it's 0 plus 0 minus 2, because in both cases we have an infinite on the lower value. Then we can assume this one is 0, the other one is a 0 as well, and we are left with a plus 1. In this case, the answer is negative 2. It's negative 2 over 1 equals negative 2. This is the final answer.
So well, now you know the hard, long, and tiring way of getting the answer of this problem when x approaches infinite. But I'd like to give you the shortcut, which is way easier, way faster, and way less heavy. So, what you're gonna do is look on the numerator and on the denominator. It's really easy. You'll only have to look for the exponents of the function. So, for example, here we have no exponent, here we have 1. What are we looking for? The biggest exponent on the problem. So here, our biggest exponent will be this 2. So we're going to take into consideration this number with that variable. Now we'll look down, and here we have a top comparator because it's an x squared, and we have a cubic x, which will be the 3, and we'll here be 1. So this won't be made totally. So our biggest exponent will be x and 3. Now why this is important? Because we're only using these two numbers. No, you see why it's a number. We're only using these two numbers, right? So what are we gonna do is just cross out every single other thing on the problem. So here we'll cross that, and we'll cross this part. So we will end up with this. Always write the limit you are approaching to. That's a really important rule raised by Pablo. Now here we have limit of x approaching infinite. We have negative 2x squared over a cubic x positive. So this is what we need right now. So what are we looking for here is not this, but this. So once you set apart this, we will be having, because, well, x is infinite and x is infinite. So basically, well, infinite won't be affected when multiplied by 2 or something, you know, because it's already a really big number. So we're only taking into consideration number 2 and number 1. So this will give us the final answer of negative 2, which is actually the same answer that is given to you on the hard and long way. And look at this, it took me less than 5 minutes, you know. So there is something you will always need to remember whenever doing the shortcut. Well, actually a few things, let me tell you. Here's the first one. Always look for the biggest exponents on the denominator and on the numerator, and cross out everything else. That's really important. Next one. Now, this rule is a personal recommendation of mine. Always do the long procedure, because the shortcut might be, well, really trustful. But, well, if you do the shortcut, you can use the long procedure to check, or the other way. Do the long procedure first and do the shortcut as a check, right? So, my personal recommendation is always be sure twice, because, well, probably your teacher will rather you to do the big procedure. So stay cool. Let's go for the next problem. Okay, now before you start hitting it with the differentiation problem, I'd like to recommend you to always know this formula and practice it a lot, which it is d over dx. This is not a negative symbol, just d over dx, when here you have another x, n equals nx n minus 1, which I know this looks totally complicated, but, well, once you understand it, it's quite easy. So basically this rule is like this. So you have a tree with a x to the 6th. So the derivative of this, okay, let me just put here f of x. When you want to find a derivative, you have to put x prime, this is really important, with x will be 3 times 6 will be 18, and according to the formula, here it will be this x6 is equal to the n, so it will be x6 minus 1, which will give you to 5 x5. This is the derivative of this, so always remember that rule, and I'll let Sebas now explain every single thing.
Hello, we will do problem number 75, finding by differentiation rule. So this is our problem, y equals 4x squared plus 6x plus 5 over root of x. And then when you do next is y equal 4x2 over root of x. You divide all of these numbers in the denominator over root of x. plus is x over root of x plus 5 over root of x. Then you know root of x is x 1 over 2 as an exponent, so it's y equals 4x squared plus 6x plus 5 over x 1 half plus x 1 half and over x 1 half. So x 1 half, you will get this y equals 4. You just in this case you just pass the x 1 half to the above and you make it negative, but also you will differentiate, so there's no problem. So you will get y equals 4x 3 over 2 plus 6x 1 over 2 plus 5x negative 1 over 2. So now you will differentiate. You pass it on to here. Y prime equal 4 times 3 12 4 times 3 12 over 2 6x, and you will rest minus 1 here, and then you will get plus 6 times 1 1 over 2 3 x plus 5 times negative 1 plus over 2, so it's 5 negative 5 over 2 x. After you differentiate and rest the negative minus 1 on all of the exponents, when you differentiate you will get this y of prime equals 6x 1 over 2 plus 3x minus 1 over 2 minus 5x 3 over negative 3 over 2. So then you see that you have negative exponents, and the ones for the final answer you need to make them square root. So the final answer will be y prime equals 6 root of x plus 3, and then as this is negative you pass it on to the denominator and you make that square root, so it's over root of x minus 5 over 2 x3 will be negative minus 5 over 2x root of x cubed to the cube, and then it will be your final answer because you pass the negative 3 over 2 to the denominator because it has to be positive. So this is your final answer.